Assalamu alaikum. Today we discuss the topic of resonance. What is resonance in AC circuit? Resonance is when the system is vibrate with very large amplitude when it supply energy at a particular frequency. So here we write that resonance is when a system vibrates with very large amplitude when it is supplied energy at a particular frequency. When it is supplied energy at a particular frequency. So let's first understand what is the natural frequency. So here we write about the natural frequency. Every system has a natural frequency, the frequency at which is like to oscillate it on. That is called the natural frequency. So here we write about it. Every system has a natural frequency the frequency at which it like to oscillate on. Okay हो गया. Now we discuss the condition of resonance. Condition of resonance when outside source gives energy at the same frequency has the natural frequency of the system. Then the resonance is happen. At this point, the system oscillate become very large. This is the condition of the resonance. So here we write about the condition of the resonance. When an outside source gives energy, when outside source give energy at the same frequency. For the condition of resonance, we have to apply the outside energy on which the system is oscillate. When an outside source give energy at the same frequency as the natural frequency of the system, as the natural frequency of the system. When the outside frequency equal to the natural frequency of the system, then the resonance is happen. So here we write about that the resonance happen. When the resonance is happen, the system is oscillated, become very large. So here we write that at this point, the system oscillation becomes very large. This is the condition of the resonance when the outside frequency become equal to the natural frequency of this system. Resonance is happen. At this point, the system oscillation become very large. Now we discuss about the series resonance circuit. In the series resonance circuit, a series resonance circuit is made with the inductor, capacitors and resistors which are connected in series. Assalamu alaikum. हेलो
हेलो, आवाज आ रही है आपको?
जी जी
अच्छा, माइक्रो चेक कर रहा था। आ गए आपके?
जी जी आ जाए। आप अभी आ रहे हैं?
10 नंबर गली है ना?
जी जी गली नंबर 10।
ठीक हो गया।
ठीक है।
आज मैं सलामी सूरत हाल पर बारिशों के दौरान मुमकिन असरात से निपटने के लिए एहतियाती तदबीर अपनाएं। एनडीएमए की एडवाइजरी और अलर्ट्स पर अमल करें। दरियाओं, नदी नालों में नहाने।
हेलो अस्सलाम वालेकुम मारिया, वो अवन ठीक करने आ रहे हैं ना, तो नफीस भाई को बाहर भेजो ना।
अच्छा, क्या बताया तुमने उसको?
मैंने तो कुछ नहीं कहा, अभी उसने कॉल किया मैं आ रहा हूँ।
नहीं, उसको पता है फिर का।
गली नंबर 10 ही कहा है, कहता है गली नंबर 10 ही है, हमारे को चीजें ही है। चलो ठीक। Okay, where we reached at, a series resonance circuit is made with inductor, capacitors and resistors are connected in series with an AC supply. So here we write that a series resonance circuit is made when an inductor L, capacitor C and resistor are connected in series with an alternating current supply. At certain frequency of alternating circuit, this circuit allow the maximum current to flow. In the resonance frequency, the circuit is allow maximum current to flow. So here we write that at a certain frequency, the certain frequency of alternating current circuit allow maximum current to flow. If we discuss about the impedance of the RL series circuit, impedance that is the opposition offered by the alternating circuit to the flow of alternating current, that is called the impedance. Here we write about the impedance formula in opposition. The opposition offered by the circuit to alternating current is called impedance. If we discuss about its formula, so here we write it. Impedance, that is always shows by Z, that is Z is equal to under root resistor R, that is shows by R, and the inductive reactance, that we know that is equal to omega L, and capacitive reactance, that is equal to 1 over omega C whole square. That is the impedance offered by the RL series circuit. Okay, now we discuss the next topic. Is electric resonance. Okay, our next topic is about the electric resonance. Electric resonance is the condition in an alternating current circuit when the inductive reactance become equal to the capacitive reactance. We know that the inductive reactance, that is equal to XL is equal to omega L, and capacitive reactance, that is XC is equal to 1 over omega C. When the inductive reactance is equal to the capacitive reactance, at this point the inductor and capacitor cancel out the each other effect. So at this point we get the electric resonance. So here we write about the electric resonance condition. Electric resonance condition in the alternating current circuit. Electric resonance is the condition in an alternating current circuit when the inductive reactance, that is always shows by XL, when the inductive reactance XL is equal to omega L becomes equal to the capacitive reactance, that is shows by XC, that we know that is equal to 1 over omega C. At this point, the effect of the inductor and capacitor cancel each other out. So here we write that at this point, the effect of inductor and capacitor cancel each other. This is the condition of the electric resonance, that the inductive reactance must be equal to the capacitive reactance. If they are not equal, then they not produce the electric resonance condition in the RL series circuit. Okay, next we discuss about the resonance condition. What we required for the produce the resonance. Okay, last we discussed that we can produce the resonant condition when the XL is equal to XC. So here we write that when XL, that is the inductive reactance, is equal to the XC, that is the capacitive reactance. And we know that XL, that is equal to omega L. And here we talk about the electric resonance condition. So angular frequency in which we get the electric resonance, it denoted by omega R is equal to 1 over omega R C. And here we simplify this equation, and we know that omega 4 square is equal to 1 over L C. Take under root on both sides. Omega R is equal to 1 over under root L C. And we know that omega R, that is equal to 2 pi f. And here we also write the frequency f denoted by fr, that is shows the resonant frequency. So what is the resonant frequency? When we get the resonant frequency, when the inductive reactance is equal to the capacitive reactance. So here we write that omega r, that is equal to 2 pi fr 1 over under root L C. And here we get the value of resonant frequency 1 over under root 2 pi under root L C. Fr, that is called the resonant frequency. So here we write that Fr is called resonant frequency. Okay, next we discuss about the resonant frequency conditions. So here we write about the at resonance frequency, at resonance frequency, that is the XL is equal to XC, XL is equal to XC. When the inductive reactance is equal to the capacitive reactance, impedance become minimum. Okay, in this case, when we talk about the RL series circuit, impedance is always minimum because XL is equal to XC and the whole impedance, that is equal to the resistor R. So in this case, when the impedance is minimum and current is maximum. So here we write that impedance become minimum when XL is equal to XC, inductive reactance is equal to the capacitive reactance. When the inductive reactance is equal to the capacitive reactance, then the impedance, that is equal to the resistor R. When the impedance is equal to the resistor R, this means that this circuit is offer the opposition to the flow of the current is minimum. When the opposition offered to the flow of the current is minimum, then the current in the circuit is maximum. So here we write that second point, that is the current is maximum. When the current is maximum, so here we can write that I naught is equal to V naught over R. And third point we like to discuss that the circuit is behave like a pure resistor. Voltage and current are in the same phase. We know that when the impedance is equal to the resistor R, and we know that in the resistor R the voltage and current are in the same phase. So here we write that circuit behaves like a pure resistor. Voltage and current are in the same are in the phase. Okay, next we discuss about the acceptor circuit. What is the acceptor circuit? We also write it about RLC series resonance circuit is also called the acceptor circuit. Where is the acceptor circuit? We will discuss it. When multiple frequencies are supplied, the circuit accepts only the resonant frequency and reject all other frequency. That is why it is called the acceptor circuit. So, series RLS series circuit is also called the acceptor circuit when multiple frequency are supplied. The circuit accept only resonant frequency, and we know that at resonant frequency the circuit is allowed to flow the maximum current. Circuit accept only resonant frequency and reject other frequency. That's why it's called the acceptor circuit. It is called acceptor circuit. That is what we discuss. First we discuss about the what is the resonance, and then we discuss the condition of resonance. For the resonance what we required, and third number we discuss about the series resonance circuit. In the series resonance circuit, when we get the electric resonance, then we discuss about the resonance condition, and last we find the resonance frequency. In resonance frequency, we discuss about the 4 points. First point is discussed that the resonance frequency inductive reactance is equal to the capacitive reactance, and impedance become minimum when XL is equal to XC. And second point is that the current is maximum. And third is circuit is behave like a pure resistor. When circuit is pure resistor, and we know that the voltage and current are in the same phase. And the series resonance circuit also called the acceptor circuit because when the multiple frequencies are supplied, the circuit accepts only the resonant frequency. And resonant frequency, that is, we know that is denoted by F sub R. That is all we discussed today. Next, we discuss about the resonance curve in series RL series circuit, and then we discuss about the uses of the resonance circuit. It's our day. We discuss in the next class. Thank you so much for watching.